All right, how are you doing there? I hope you're having a great time. This time, I hope your pencil and paper are ready. This time, let's solve problem number 2. Let x, y, and z be positive real numbers such that xy plus x plus y equals yz plus y plus z equals xz plus x plus z equals AP. Find the value of the product of x plus 1, y plus 1, and z plus 1. I am Dr. Kim JC Ensho again, and give this problem a try. Pause the video for a while, and if you are ready, you may confirm if you have the same answer as I did. And if you did, that means you got the problem right. And I will reveal the answer in 3, 2, and 1. So, I will present to you two solutions. The first solution that we have here, you will notice that this statement can be true if x equals y equals z. And take note that for this particular solution, I made the assumption for a while, for now, that how about if all the three numbers are equal? How about if x, y, and z are equal? And so for the first equation here, how about if I pick x equals y? So the first equation was xy equals x plus y. So replacing all y's with x. So we have x times x plus x equals AP. And the product of x and x, that's x squared. X plus x is 2x. So we have x squared plus 2x equals AP. Subtracting both sides by 80, we have x squared plus 2x equals 80, minus 80 equals 0, which is in fact factorable to x minus 8 times the quantity x plus 10 equals 0. And equating each of the factors to 0, we have x sub 1 equals 8, or x sub 2 equals negative 10. But for this particular case, we have to pick x equals 8 since based on the given, x, y, and z are real numbers. So this means that negative 10 here is an extraneous root. And hence, we pick x, y, and z to be equal to 8. And with x, y, and z equal to 8, and by substitution to this equation or to this statement or expression, we have the product of 8 plus 1, 8 plus 1, and 8 plus 1. We know that 8 plus 1 is 9. And this becomes 9 times 9 times 9. And that's 9 cubed or 729. Hence, the correct answer here is 729. But that's the first solution. How about if I present to you the second one? If in the first solution, I made the assumption that x, y, and z are equal, for the second solution, I will not make that assumption. And equating each of these expressions to 0, we have xy plus xy, xy plus x plus y equals 80. The second one here, it's yz plus y plus z equals 80. And the third one is xz plus x plus z equals 80. And the next thing that we have to do here is we have to add 1 both sides of our equation. And you will know the reason later. So adding 1 to each side of this, we have xy plus x plus y plus 1 equals 80 plus 1, which is 81. The same thing was done with the second equation. So we added 1 both sides. So we have yz plus y plus z. Yz plus y plus z plus 1 equals 81. And for the third one, adding 1 both sides, we have xc plus x plus z plus 1 equals 81. And with these three equations, if we have the first equation, we could actually see that the first equation could be factored. The left-hand side of this first equation could be factored to x plus 1 times the quantity y plus 1. So to check, you may perform the FOIL method. So x times y, we have xy here. X times 1 will be x plus x. 1 times y will be positive y. And 1 times 1 will be positive 1 or simply plus 1. That's why this is the correct factored form of the left-hand side, equals 81. Also, doing a similar thing to the left-hand side of the second equation, this becomes y plus 1 times the quantity z plus 1 equals 81. And for the third equation, we have x plus 1 times the quantity z plus 1 equals 81. And we have a property in algebra that if A equals B, C equals D, and E equals F, then the product of the numbers in the left-hand side, namely A times C times E, or ACE, is equal to the product of the terms on the right-hand side. That is B times D times F, or BDF. And performing such with this one, if we multiply the left-hand side, we could see that we have x plus 1. If we multiply everything here, there are two x plus 1s. That's why their product, it's x plus 1 quantity squared. There are also two y plus 1s here. So that's y plus 1 quantity squared. And we have two z plus 1s as factors. So that's z plus 1 quantity squared equals 81 times 81 times 81, or that's 81 cube on the right-hand side. Now, what we are after is only the product of x plus 1, y plus 1, and z plus 1. But since you could see that they are all squared, hence we need to get the positive square root of both sides. I just have the positive square root of both hand sides instead of placing a plus and minus, because all the numbers here are positive real numbers, and that if you add any real number by 1, any positive real number by 1, it will be positive. The product of the three numbers will also be positive. Hence, I took only the positive square root, or the principal square root. And getting the square root of both sides, so all the squares here will be canceled because of this radical sign of the square root here. And what is left on the left-hand side is the product of x plus 1, y plus 1, and z plus 1 equals, if you wanted to get the value of this, so you may get the cube of the square root of 81. That's a property in algebra of our radicals. And with such, the square root of 81 is 9, but we still have to cube that. And we know that 9 cubed is 9 times 9 times 9, which is 729. Hence, x plus 1 times the quantity y plus 1 times the quantity z plus 1 is equal to 729. So you see, with solutions 1 and 2 being the same, we were able to show that this is correct with two different solutions. And before I end, let's have our quote of the day. Why fly like a barnyard hen when you can soar like an eagle? By Saint Josemaria Escriva. So I'm hoping and praying that we will do our best in whatever that we do. And with that, TYVM, thank you very much, and a great day to one and all.